In today's session, we're going to learn about conditional statements. And in conditional statements, we have other statements that those other statements are executed depending on whether a condition is met or not. This is a simple program where we have a variable x and that has been initialized with value 5. Next, you see there is a statement that starts with if. So this if is a conditional statement, okay? And the grammar of this if structure is that the keyword if, and then you have a comparison between two values. These two values can be two constants. One can be constant, another can be variable. As you know, when you use a variable, if the variable is not on the left side of an equal sign, then the value of the variable is actually used. So here, instead of x, it's going to compare 5. The value of x is 5. So it's going to compare with the 5 is less than 10. Right? So it's asking a question, is 5 less than 10? In other words, it's checking this condition if 5 is less than 10 or if x is less than 10. Then you have a colon, okay? And in the next line, you have an indentation. You can use a space, you can use tab. So this indented line executed only when the condition in the if is true or met, okay? In other words, if the condition of this if statement, which comes right after the word if, is met, then the indented statements are executed. If the condition is not met, then the indented statements are not executed. We can have one or more indented statements. Okay, so all the indented statements will be executed when this condition is true. Those indented statements will not be executed if the condition is not true. Now let's look at the flowchart, what is happening here. We generally use a variable in a condition, and we will have a value before that if statement or conditional statement. It can be a constant, it can come from user input. So we have a value, okay? And then if we look at the arrow, direction of arrow, then we have a diamond shape. Diamond shape represents a condition check. So we're checking a condition. If the condition is true, then we are executing one or more statement, which is represented in the rectangle box. And if the condition is not true, eventually we reach to the same point. In other words, here the printf statement will execute only if x is less than 10, will not execute if x is not less than 10. And then comes the next statement, which is aligned with the previous if. So next statement is just a normal flow of execution in the program. There's another if statement in this example, and these two if statements are completely independent from each other. So let's try to run some code. I'm going to use Replit today, but we're going to use also Visualizer to see how the flow of the execution goes. I'm going to take one variable, x equals 6, and the variable y equals 10, suppose. Now, I'm going to use the conditional statement if. The grammar of if is the keyword if, okay? And then a space, the condition check. We can check two variables, we can check one variable and the value. We can check in different ways. So let's say if our first number is x and second number is y. So if x is greater than y, okay, so this is the condition, and then we have a colon, right? And when I press enter, it goes to the next line, but because this site is designed that way, it automatically indented. Okay, and in most of the environment, whatever you use for writing Python code, it will identify that it needs indentation. If you don't put indentation, then it will show an error. We'll see. So we can say, let's say first number is x and second number is y, irrespective of what the value is. If we are saying the first number x is greater than y, then we can say the first number is greater, okay, or bigger. Okay, now if I run, what will expect the output? Let me use another print statement, but that will not be indented. Okay, print end of the program. Okay, now if I run, it's simply saying end of the program. It did not execute this line, and the reason is this condition is not true. If we compare this value, x is 6, y is 10, so x is not greater than y. That means this condition is not true. That's why this indented line did not execute. Okay. Also, I'm going to show you that if we don't put indentation, then it is showing an error. As you can see, it's red underline, which is an indication of that error. Also, if I try to run, it's going to say error. So, after if you want to execute any code that depends on whether the comparison gives you true or false, then you need to put them in indented. Okay, and I can use more than one line and indent it. And let's say another. This is second line under if. Now, if we run again, just again say end of program. That means it did not execute either of those two print statements. If I change the value of one of them and make that true, for example, let's say x is 6 and y is 1. So this condition is true, right? And then what will happen? If this condition is true, then all indented statements will be executed. So let's run, saying that the first number is bigger. This is the second line under if, did execute, and this is natural flow. After this if statement, the next statement is print. Okay, so only these two statements depended on whether this condition is true or not. Okay, if this is true, then all the indented statements will be executed. If not, then those indented statements will not be executed. And then the last print line on line number 6 is independent of what happens in if or not. Let's check another condition. If, now I'm saying if y is greater than x. Okay, so again another column, and then we're going to say the second number is bigger. Since our first number is x and second number is y, if y is greater than x, then the second number is bigger, right? And then we can run, and it says the first number is bigger, which is x, second number was y, and the value was 1. So this condition was not met. Okay, the second if, in the second if, the condition whether y is greater than x did not meet or was not true. Y is 1 and x is 6, so y is not greater than x, so it did not print this one, it only printed this one. Okay, we can make another if, maybe let's say if x equal y, and then a colon, and then what we should say? We should say they are equal, right? Yes. Sorry, once again. Was that a question? Now it's showing red underline. That means something is wrong in here. Okay. Even if we use a plain editor like Notepad, it will not show red underline. But when we execute, it's going to show that something is wrong. Do you know what is wrong here? Can anybody say what is wrong in this line? Why it's showing an error? Remember when we say x equals y? What type of a statement is this? This is an assignment, right? The variable value on the left side of the equal sign will be changed to the value on the right side of the equal sign. So the x value will change. Here I said if x equal y, here it means that I'm changing the value of x. But the grammar of if statement needs, after if, you need to have a comparison, okay? A condition check, a comparison. Now, this assignment is not a comparison. It simply assigns the value of y into the value of x, right? So this is not a comparison. So how do we say equal if x is equal to y? Because we already know that if we type in x equal y, that means it's changing the value of x. So how do we compare if x equal y? We need two equal sign. When we use two equal sign, then it's making a comparison between x and y. Okay. So now our program is quite complete. Either x can be greater or y can be greater, or they can be equal, right? We did run with this initial value. Now let's make x bigger. It will say only it will print this line, right? We did. Now let's change the value of any of them. Let's say 9. Now y is bigger than x, so y is greater than x. So we expect that this line will be executed. The second number is bigger, we did say that. And then if we make them equal, then both numbers are equal. Okay, so this condition is not met, this line didn't execute, this condition is not met, this line didn't execute, this condition is met, and this is a condition. If x equal y, equal, double equal makes a comparison. Okay, this condition did meet, and that's why this printf statement did execute. And this last printf statement is not under any of these if statements. It always executes. Now, what I said, now we can make it a little bit interesting. Instead of putting a fixed value for x and y, we can take inputs, right? So remember how do we take input? When we take input, it is a string. So we always do casting or convert into a number when we use number, and then input is the function to take input. In bracket, we give a prompt to the users or give a message to the user. Enter the first number, let's say. Okay. So, and then we need to close this bracket because this casting needs opening and closing bracket. Similarly, we can say input, enter the second number. Now, every time I run the program, I can give different values, right? And I don't need to change the value inside the program. If I put a fixed value inside the program, that's the programmer controlled. The user doesn't have any control. User cannot compare with different values. Now we give the user to the freedom to use any number, and then accordingly the user will get message. So enter the first number, okay, say 23, enter the second number, 44. So expectation of the output would be the second number is bigger, right? And I will put a little gap here so that it looks nicer. Run again. First number, now 22. Second number, also 22. Both numbers are equal, right? All right. So we did see how to use if. Actually, if has some other component which are optional. If has an else option, else. So let's use that else. I'm going to change this, only keeping the if part, and then else. Again, a colon, and also indented statements. Else means this else part will execute, okay, if this is not true. When we used if, we executed some code when the condition is true. Only when the condition is true. And we didn't do anything if it's not true. Now we're going to say, if it is not true, then do something. Then execute some other code. Okay? So what can we say? If x is not greater than y, that means the first number is not greater than the second number, we can say print the first number is not bigger. Okay, so if this is true, then it will execute this print line. If this is not true, then it will execute whatever is under else. So it will execute this line. So let's run. 2 and second number is 3. So first number is not bigger than the second number. Okay, so it will say the first number is not bigger. Okay, run again. First number is 7 and the second number is 5. The first number is bigger. We don't have equality check here. We could only say first number is not, whether first number is bigger or the first number is not bigger when we have if and else. Okay, we could not say when whether they are equal or not. All right. Now this, as you saw that when we used if first time, we didn't use else part. So this else part is an optional component. Okay, and else part will execute only when this is not true. Okay. Now the if else statement, where else part is optional, it can have more components, and those are also optional. Okay, and that comes before else. ELIF. The full word is else if. It's called else if. In other languages, it's called else if. Okay, but in Python, ELIF. Again, you can check another condition right here. Elif. Okay, and if the first condition is not met, then it will come to this line and we'll check this condition. So we can check here if y is greater than x, and then we can say print the second number is bigger. The else component or else part will execute when this is not true. When this is not true, then the else part will execute. So if the first condition is not true, then it will come to the else if. If the first condition is not true as well as the second condition is not true, then it will come to the else. If the first condition is true, it's not going to come to the second condition, will not even check, and will not even come to the else part. Okay, but as a whole, from beginning of if and the indented statements under else, this whole thing is one compound statement, you can say. Okay, one compound statement. It has if, elif, and else. This elif and else, these two components are optional. Okay, you may have elif, you may not. Also, you may have else and may not have else. But if we carefully check the logic, this should not be the message, right? What should be the right message here? X is not greater than y is not greater than x. So what other thing can be? Anybody? They are equal, but we don't need to check that condition. The only thing, if this is not true and this is not true, then it will execute this. And then that means if x is not greater than y, if y is not greater than x, then that means automatically they are equal. So you don't need to check that. Okay, so you can say both the numbers are equal. Now we can run. First number 4, second number 9, second number is bigger. Run again. First number 7, second number 3, first number is bigger. Okay, run again. First number 8, second number 8, both the numbers are equal. Now, to actually visually see what happens, let's go to visualizer and see the flow of execution. Okay, so enter the first number, we're giving say 7, and then taking the second number, so 3, we have x7 and y3. Now it's checking, look at, observe the red arrow. If x is greater than y, which is true, right? So it came to this line 4 print statement, and then what happens? Look at the arrow. If I go, did you see it jumped out of if else? It escaped everything else. So as soon as this condition is met, it's going to execute all the indented lines, and then it will not even come to this if. Okay, so let's and then of course end of the program. Let's run again. Now I'm not gonna make this condition true, so I will give x a smaller value and y a larger value. So it's going to check this condition in the if, and it's not going to be true, right? Because our x is 5, y is 9. And observe the arrow, the red arrow. Okay, next. So it did not execute this print. It came to next elif condition check. Now it's going to check if y is greater than x, which is true. And that's why it came to this line number 6. It's going to print that second number is bigger. And it escaped the else part. Once this is met, it escaped the else part. Okay? So in an if else statement, it kept checking the conditions. Once the condition is true, it escaped the rest. If none of the condition is true, then it executes the else part. Okay, so let's run again. This time I'm going to give equal 3, and second number is also 3. Now checking if x is greater than y, which is not true. So it came to second condition check under elif. If y is greater than x, which is not true, so it's coming to the else part. Okay, this condition is not true, this condition is not true, then the only thing possible is they are equal. That's why I didn't need to write anything here. If they are equal, I did not need to write that. Okay, so the only thing possible is they are equal. So I simply can print both numbers are equal. I can modify this code in different ways. I could check here if x is equal y, and then I could say both numbers are equal. Logically or algorithmically, it doesn't change anything. It's algorithm wise, it's the same code. Okay, same program. First, we are checking if x is greater than y, then saying the first number is bigger. Else, if x is equal to y, then we're saying both numbers are equal. If this is not true and this is also not true, then only thing possible is y would be greater than x, right? So that means the second number will be greater than x. So I don't need to check that condition. All right. So if we want to run it that faster, we can run it here. The same result, logically, same result we expect. Just make the first number bigger, second number smaller, and then run again. First number smaller, second number bigger, run again. Both numbers are equal. Okay, so if x is greater than y, if x is bigger, or they're equal, if none of these two are true, then the only thing possible is that y would be bigger, or second number would be bigger. Okay, that's why I wrote it under else. Let's go back to slide and let's see if there are some other examples. There are other examples. So we did check bigger only, right? But there are other comparison operators. These are operators. Okay, sorry, this is a smaller sign, not bigger sign. We did check this one later. This is a smaller sign. So we have a couple of other comparison. This is smaller, and then this one is less than or equal to. Less than or equal to. It's not less than and equal to. Okay? Because less or equal to. So if we have here x and y, this type of comparison, okay, between two variables. What we're saying, if x is less than or equal to y, so this condition will be true. Let's say if x is 5, y is 7, this will be true. Yes, x is less than y. Also, if x is 5 and y is 5, then also this will be true. If x is less than or equal to y. So this comparison gives you true result when x is smaller. Also, it gives you true result when x is equal to y. We used equal. This is comparison, equality, and greater than or equal to y. So this comparison will give true result when the number on the left side is greater than the number of the right side, or the number of the left side is equal to the number of the right side. And this is greater, and the last one is not equal to. Not equal to. Okay, so we can use some of these. Let's say let's enter age. Okay, let's take one number, and then we're gonna this. Suppose if the age is greater than 18, then we can say adult, right? Also, if age is equal to 18, then we can say the person is adult. So now we can say if x is greater than or equal to 18, then the message would be you are an adult. If not, then we can say you are a child. So here we are checking if x is greater than or equal to 18. So for a person of age 25, we'll say adult. Let's say 20, adult. Run again, 18, adult. Run again, 17, child. Run again, 2, child. Right. So this time we are putting we're putting a number and inclusive that number. That means the comparison also says equal to that number. Okay, greater than or equal. Be careful here. It's a greater than sign comes first. Okay, if you say equal or greater than, it's not going to work. Okay, this is wrong. So the greater than or equal, all right, this is the right comparison. If I want to use for the same problem, I want to solve the same problem, user will give an age and then it will say child or adult, but I want to use less than or equal to. What changes should I make? Less than or equal to. I want to use less than or equal to. What change should I make to write the program? Anyone? I want to use less than or equal to. Okay. But program logic should work in the same way. If I enter 18 and above, should say adult. If I enter less than 18, should say child. Okay. That's the requirement. But in the code, I don't want to use greater than or equal to. I want to use less than or equal to. So what changes should I make in the code so that the program works logically in the same way, but I can use less than or equal to? One proposed solution was less than or equal to 18. And then this should be child, right? And this should be adult. Is this correct? I can say it's not. Here is the proof. 18 should be adult, right? But look what the program is saying. It said you are a child. Used less than or equal to, but algorithm is not giving the right result. So I need some other change. What other changes do I make? Well, I can use if, but I simply need to change this. It includes 17, right? Includes 17. When I say less than or equal to 17, yes, up to 17 is child. So I need to change up to 17, less than or equal to 17. And this time, if I say 18 as input, it's going to say adult. If I say anything less than 18, it's going to say child. All right. So not equal to. Let's try to use not equal. Okay. So it compares only equality. Okay. We cannot put a range. If we like adult and child, it's in a range. But if we want to say not equal to, so probably I have to use a different example. So let's take inputs, another input. this would be y, and if x not is exclamation sign, okay, and then equal, not equal to y, then they are not of same age. There is no else. Well, we can put else. They are of same age. If x is not equal to y, that means they have different age, right? And if this is not true, then it will execute this else part. So when it doesn't matter what age I put 5 and 5, so they are not equal, x is not equal to y, it will not execute this part, it will execute the else part, and they are the same age. If I run again and give a different age for them, then they're not of the same age. Okay. These are very simple examples. Let's go back to slides and let's see. I did use equal, greater than or equal, less than or equal, not equal. And there is no really significant algorithm to solve. It's simply comparing the variable with the constant and saying whether this is greater, equal, or so. Here is another comparison. Here 3 lines of these 3 lines will be executed if x is equal to 5. If x is equal to 6, all these 3 lines will be executed. They are indented after if. And after if, it will look for a statement that is not indented, and then it understands the end of if statement. Okay. If we have else or elif that we saw, that also we have indentation. Integer in this program. So there is a question: can we assign a variable to an integer in this program? Of course we can. So let's go back in here. We can use any valid Python code we can write. Okay. Let's say if x is not equal to y, then put x equals to y. Change the value of x and make it y. Okay. So maybe not age. We don't want to change a person's age. Enter a number. Enter another number that are not the same, and then let's say make them the same. Okay. Actually changed the value of x. I can put a value here as well if I want, any constant value, any number. And then say no change in numbers. Okay. Whatever message we want. The question was, can we assign a variable to an integer in this program? Of course we can. Here is an example. The integer value of y is going to get assigned into x. So I'm going to do I'm going to put a constant, and also then I'm going to change one variable value into another. Okay. Any number of a statement, any statement we can put in here. 4, 5. They're not the same. Made them the same. Program ends. Made them the same. But how do you know? Actually, let's check. In here, we can actually see what is. Next. Okay, so if I go to visualizer number 2, 6, 2 and 6, right? X is not equals to y, so this is true. So it's going to come here. It's going to come here, here, and here. All these 3 lines will be executed. Here X is gonna change to 6. Okay, date changed to 6. All right, the value of y, it changed to the value of y, and I can use any number here if I want. Anyway, so so the importance of indentation is that if you do not put indentation after the if statement, then it's going to show an error. So you need to have at least one statement with indentation. But if you by mistake put no indentation, then the if statement ends here. Okay, that if statement ends here, and if you indent like this is going to show error as well, because you're not supposed to have indentation here. All right, so you need to have same indentation for every line, okay, that you want to execute depending when this condition is true. The same as in elif as well as else. In every case, the indentation should be the same. However, we can have more if statement in an indented form. We're going to take a look at those examples. So here's some warning. We can use space or we can use tab. Okay. What it's saying is different environments such as Notepad++, so it's like a editor, text editor, but many people use it for writing code. If you use tab for indentation and it doesn't automatically convert to spaces, then you may disable tab in the environment. So this is talking about different environment. It could be Anaconda, it could be Notepad++, it could be any other environment where you write code. If you need, you can disable tab, okay, in its setting, the editor setting. Here is another example for indentation. This is using a for loop. I'm going to quickly go to this for loop, okay, and I will briefly explain. We're going to look at for loop in detail later. So the focus is indentation. Okay, let's say print I. What this is doing is that it is declaring a variable I, and the variable I is taking different values. If I want to change different values of I, then we can use the range function. What it does is it gives us different values starting from 0. Okay. Another form of range is 0, and then I can say what is the second number. So this is the first number and this is the second number, will automatically increase by 1. So for I in range, you don't need to say the first number. If you don't say, it's automatically 0. So what it does is for I in range 5 means for I is 0 first time it execute. So for is a loop, so it's gonna loop through this print statement multiple times. And how many times? First time I will be 0, second time I will be 1, third time I will be 2, 3, 4. Okay, 5 is not included. Okay, so when I print I, it's gonna print 0, 1, 2, 3, 4. But here's the indentation is the point. Indentation is the important part. For is a loop, while is a loop, and to execute any number of statement under the loop, you need to put indentation. So if I run, it's showing 0 to 4. What happened? This I took the value of 0, 1, 2, 3, 4. That's what the range does. Okay, for I in range. If I do 15, it's gonna run from 0 to 14. Okay, and there are other use of for. We will see more example in future. Okay, let's say another example. 0, 2, 4, 6, 8. Anyway, so this range is not the focus here. The focus is indentation in for loop, and for is a loop statement. It repeats the print statement multiple times. How many times depends on what we use here. Also, similarly, while is a loop, we're going to look at those in another class. All right, I explained it so that you understand this code. Okay, here simply if x is greater than 2, then print this 2 line, and then print this line irrespective of what happened in f. And then the next line is another for I in range. So it is printing I taking the values from 0, 1, 2, 3 up to 4. Okay, and then inside we have another if, and this if has its own indentation from where the if started. So this indentation is also necessary. This if has its own indentation. Right. The next is nested condition. Nested condition means loop inside, if inside another if. So let's take a variable age equal integer input. Enter the age. So we have age from user, right? Now we're going to say if age is greater than 18, then we're going to say print adult. Else. That means not greater than 18. Actually, should be more than greater than 17. Okay, that means including 18, right? Greater than 17 means 18 and above. So if age is greater than 17, then you are an adult. Now, I don't just want to say adult and child. I want to say teenage as well. Okay, so in the else part, when it comes to the else part, when this is not true, that means any age between 1 and 17 will come to the else part. Okay, here I'm going to use another if. If age is less than 12, less than 13. So 13 starts teen. Then we can say print you are a child. And here I can say else print. What should be the message here? Guys, what should be the message here in this print? Think logically. Okay, what is the logic of this program is using? Taking age as input, and if the age is greater than 17, like 18 and above, then it's going to say you're an adult. Fine. If that is not true, then it will come to the else part. That means the age is given as either 1, 2, 3, 4 up to 17. Now, from that range, I'm saying if age is less than 13, so that's a child. If that is not true, then what does this mean? This else part, what does this mean? What is the age in this part? When it comes to this else, okay, what does this mean? What is the age range? When this code will execute, what is the age range? So the age range would be 13 to 17. So you can say you are 18. Now, if I run, just quickly want to see the result. So the result, and then saying 15, 13, correct, and then 10, you're a child, is correct. Now let's look at the flow of execution. Okay, so we're going to go to visualizer and execute one line by one line. So adult age first. This is going to be true. It will not come to the else part. It will stop after executing this line. It will skip the rest. Okay, observe the red arrow. It's printing you are an adult, and then program ended. It didn't come to the else part. Okay, now run again. This time I'm giving 14. The age is not greater than 17, so it will not come to line 3. It will come under line 4, but it will not pause here. It will go under else. Okay, observe the red arrow. It did come under else. There is no condition here, so there is nothing to check. Okay, so it was not greater than 17, so it came to the else part. That means 17 and below. Now we can check if the age is greater than 12, or we can check if the age is less than 13. Anything will work. If the age is less than 13, that means 1 to 12, then you should say you're a child. If this is not true, then it will come to the else part. So it was not true, or age was 14. It was not less than 13, so it did not execute this part. It did execute this part. Okay, and then run once again. Now we are giving child age. This is not true, so it came to the else. Now it's checking if this is less than 13, which is true, so it's going to come to line 6. The arrow came to line 6. It's going to execute, and it will skip the else part. Program ended. Okay, so here you can see this if actually started from here and ended on line 8. It has 2 branches. This indented one line in one branch, and another branch is everything under else. However, under else we have another if else. Okay, now I could use a different logic. For example, let's say if the age is greater than 11, let's modify this code. That means teenage and adult, right? If not greater than 11, then we can say child. So keep this line and remove the rest. So if the age is greater than 11, I have to fix this part, okay? But else part is fixed. If it is not greater than 11, then a child. And here we can put another nested if. If age is it's already greater than 11, we don't need to check if it's greater than 11 again. We need to check if it's less than 18. Age is less than 18. Then you are a teen. Then print. If not, it's already greater than 11 and not less than 18, right? So that if not means else. I should say you are an adult. So the logic is, let's say input is 20. So this is greater than 11 and then not less than 18. It's gonna come to here. It's gonna say adult. Input is 15. It is greater than 11. So it's gonna come inside here. And it is less than 18. So it's gonna print you 18. Okay. All right. Now to run fast. Okay, let's run individual program. So say 20. This is true. It's greater than 11. And then 20 is not less than 18. So it's going to come to the else part on line 6 and print this one. You're adult, and then done. It did not go to this else because it's already inside this if component, right? Inside this if block. So it did not come to this else block. And in the nested if else, it will go either this part or this part. Again, in the nested if else, we can put if, elif, and else. Okay, so that's nested if else. All right. We have seen if else. We have seen if, elif, else. Actually, you can put many elif, not just one. You can put many of them. Okay, so let's take an example where we have multiple condition. Let's say marks. Enter the mark. And then we're going to put grade, okay? Depending on mark, we're going to put grade. Let's assume that if it's 90 and above, that's A plus, okay? I don't know exactly what is your grading system, but let's say, let's put a remark here, 90 and above, A plus, okay? 85 and above, A, and so A, and 80 and above, B plus. So you know the rest how it would be. Okay, so we're taking an input and then we're saying mark. Let's put this one mark. So mark if it's greater than or equal to 90, then you got a plus. Now we're going to use elif. Okay, and elif needs a condition. Mark is greater than or equal 85. Then we need on else at the end, but let's copy this component, print got A, and then repeat this 80, 75, 70, 65, 60, something like that. Okay, A and then B plus, and B. So we need to change the condition here as well. This would be 80 and 75, then B and then 70, B C plus 65, C, okay, and then 60, D plus, and we need one more, 55, and then it will be D, and let's say 50, then you just passed, okay, and then if less than 50, then that means nothing happened out of this, so that means you failed. So we're considering 90 and above, A plus, 85 and above, A, 80 and above, B plus, and so on, okay, and 50 is the plus mark. Now if I run 99, A plus, and let's say 67, C. What is happening here, if I go and execute line by line, it's going to start checking this condition every time. When this is not true, then it will check this condition. This is not true, it will check this condition. It will keep checking until a condition is met. Okay? It will keep checking from top and will go to elif until a condition is met. If none of the condition is met, then it will execute the else part. So let's put 52, that is just passed, okay, maybe just passed, and then if it is not 50, less than that, then you failed. All right, now let's quickly check this and see what is happening. Let's say I want to put somewhere around 60 something as input. So execute, and input is 62, suppose. So observe, it's going to check this one, okay. Let me zoom out a little bit. It's going to check next condition also, next condition also, next condition also. When all of the above conditions are false, okay, and one of the condition is met, then it will jump out of this if else. This is true, or mark is 62, so it is greater than 60, okay, so that's true. It's going to print, you got D plus, and then it will skip the rest, end it. If I run again and only give a fail mark, such as 40, submit, it's going to keep executing and checking every elif none of them are true, then it's going to execute else. All right. Okay, so let's go back. Let's see what else we have. So these are different values of this code. The last item is try except in today's last item. So try except format is starts with try colon, and in indented form you can have one or more statements. Okay, and then except again one or more statements. When we use this is not a typical use of try and except. We don't use it frequently. Sometimes you know that if a user is supposed to give a number but user gave a string, then we try to convert it. If we do not put in try except, then it will show an error and stop executing. If we put in try and except, the except part will execute if try fails, but the difference is that the program will not stop. Okay, it will either successfully execute the try part or it will execute the except part. If you simply write the code and it cannot convert, for example, a text trying to convert to a number but it cannot convert, then it will stop executing. It will show an error and stop executing. Okay, but if you use try and except, then it will not stop executing. It will either execute try successfully or it will execute except successfully. Look at the example in the slide and you will definitely understand. And that's all for today. Thank you, everyone.